The second flap on your conditional probability notes on page 142 in your notebooks involves using something called tree diagrams. Tree diagrams are just another way of organizing the information that you're going to use to find some conditional probability. Okay, and they usually involve using decimals. So we don't use percents for these, we use decimals. And so a tree diagram is called that because when we get ready to draw it, it's going to look like a tree. Okay, so here's what the example says. A student made the following observations of the weather. On 28% of the days, the sky is mostly clear. So I'm going to just write that basically means the same thing as being sunny. Okay, mostly clear, we would probably classify that as sunny. So I'll say S equals sunny. During the mostly clear days, or sunny days, it only rained 4% of the time. So it was sunny when it started out, and later in the day it rained, only 4%. During the cloudy days, so I'll say C is cloudy, it rained 31% of the time. So here's how I'm going to start my tree diagram. My tree diagram is going to look something like this. It's going to start here. I'm going to put S for sunny and C for cloudy. So on any given day, it says that 28% of the days are mostly clear or sunny. So I'm going to write that as 0.28. Now, 100% would be the total, right? So if you do 100 minus 28, that gives you 72. So this essentially means that 72% then are cloudy. Maybe they live in Seattle. 0.72. Okay, so 28% of the days are sunny, 72% are cloudy. Now, on any given day, whether it starts out as sunny or cloudy, it might rain or it might not rain. So I'm going to do R for rain and NR for not rain. So on a sunny day, it says it only ends up raining 4% of the time. So 0.04, which means that on sunny days, it's more likely to stay sunny. So if I do 100, that means that I would be left with 96% of the time it doesn't rain on those days. So 0.96. That's rain and not rain. It's not going to rain most of the time when it starts out sunny. Now on cloudy days in this particular place, it can rain or not rain as well. And it says during the cloudy days it rained 31% of the time. So 0.31, which means that the remaining time is going to be 69% that it does not rain on that day. So I'm going to put 0.69. And then these numbers are going to be used to find some conditional probability. And these are a little bit more complicated than the ones we did with the two-way frequency table, okay? So the first one says, find the probability that a day will start out clear. So that would be this, okay? And then rain, okay? Now you might be thinking, okay, so starting out clear and then raining. You're basically saying, okay, you're thinking, oh, well, that's only 4% of the time, okay? It's actually got the word and in there. So when it's an and, it means we have to use our probability of independent events, okay? Two independent events, starting out clear and then raining, okay? Two independent events, okay? So I'm going to have to do the probability of it being sunny and raining. Okay, that and means to multiply. So this is my probability that I'm going to be doing here. I'm going to be multiplying the two events, okay? Because again, that's going to give me a smaller percentage, okay? So if you want it to both be sunny and rain, we have to multiply them. So the probability of it being sunny is 0.28. That's what we have right here on this line here that goes from the beginning to where it says sunny. And then the probability of raining on that day is this line here. On a sunny day, it rains. That's 0.04. If I multiply those together, I'm going to get 0.012. I'm sorry, 0.0112. If I move that decimal, that means I only have a very small chance of it raining for it to being sunny and raining. Okay? It's going to be only a 1.12% chance. Okay? Now, the second example says find the probability that it will not rain. Okay, well, there are two conditions in which it might not rain. It could be that it is sunny and not rain. Or, I'll do it this way. And it could be, I should say or the probability that it is cloudy and not rain. Okay, so there are my two possibilities of what it could do and when are the possibilities of when it could rain. Okay, so at this point I'm going to have to find out a little bit more of a complicated problem now. I'm going to have to do, see how it has the or in it, but then inside it also has and, right? So what is the probability that it will be sunny and not raining? Okay, so I have to do an and, so that's going to be a times. Then whatever I put there, I'm going to add that because or means to add. Or means it's one or the other. So then I'm going to do the probability that it's cloudy and not raining. Okay, so the probability that it is sunny or ends up as being a sunny day in this area is that 0.28. So 0.28 times, I'll make that a little bigger so you know it's times not raining. Well, it's not going to rain on 96% of those days, so 0.96. Then I'm going to add that to the probability that it is cloudy and not raining. Well, the probability that it is going to be cloudy is 0.72, so it's pretty cloudy in this particular location. Times, I want it to be cloudy and not raining. The not raining part is the 0.69. So to find the probability of it not raining, I have to find the probability of it being sunny and not raining, plus the probability that it's going to be cloudy and not raining. So if I multiply these two together, I get 0.2688. And if I multiply these together, I get 0.4978. So if I were to add those up, I'm going to get the probability of it not raining is equal to 0.7656, or about 76.56%. Okay? So there's a good chance it's not going to rain. Even though this place has a lot of cloudy days, there's still not a very strong likelihood of rain. Okay? So 76.56%. You have to read carefully when you're looking at these problems and look for the and the or. The probability of that it will not rain could be in two different situations. Cloudy and not raining, or cloudy and not rain, or sorry, sunny and not raining, or cloudy and not raining. Okay? So the or means you're going to add them together, but within that category, I'm looking for two independent events. I want it to be sunny and not raining. I want it to be cloudy and not raining. Okay? So that's where the multiplication comes in, but then at the end I have to add the two together. So hopefully that makes sense to you on tree diagrams. There's several more examples in your book that you can look at and get the answers to, and that might give you some more practice. And you can always search the internet as well.